Hi, my name is Anke, and I'm going to talk about a simulation framework for connecting in-body nano communication with out-of-body devices. I also wrote my bachelor thesis on this topic, and I'm still a bachelor student at Paderborn University. To get into the topic, I created an introduction video. Why do we even need a simulation framework for connecting in-body nano communication with out-of-body devices? This year, a virus called COVID-19 has turned all our lives upside down. If you look at the Spanish flu, COVID-19 was not the first virus that caused a pandemic. What was or is the biggest problem of this pandemic? The problem is mainly time. We are currently not able to develop new medicines or vaccines fast enough. This is due to the fact that a lot of testing is needed to see how the drugs affect the virus, because at the beginning of such a pandemic, little is known about it. So imagine if known technologies such as sensors were used not only outside the human body but inside as well. This would mean that we could gain a much better understanding of the body's processes and thus be able to act faster and more efficiently. In order to gather data or to even send commands to sensors, we need to build up a network between the sensors within the body. And further, we need an interface to be able to communicate to devices outside of the body. Since carrying out experiments on humans could be life-threatening, we decided to develop a simulation framework. Within this simulation framework, we need to simulate the physical environment. For this, we used BloodVoyagerS. BloodVoyagerS was implemented as NS3 module by some people of the University of Lübeck, including Regina. It is a simplified model of the cardiovascular system of a human body, and it also simulates nanobots moving around in it. Based on the position of the nanobots, we created a communication paradigm called proximity approach, which I will explain in more detail on the next slide. Here you can see the whole framework. It consists of 4 parts, and BloodVoyagerS is one of them. The other 3 parts are communication paradigms, and 2 of them are implemented in an abstract way, which can later be exchanged by a more realistic paradigm. The connection that was implemented realistic is the connection between smart device and gateway. This connection uses the wireless personal area network standard, which has also an implementation in NS3. On top of this connection, we build an application layer to be able to address nanobots. So the second connection is the connection between gateway and nanobots. For this connection, we used a proximity approach. If the nanobot is in the left heart chamber, it can copy a packet from the gateway because the gateway is positioned on the left chest. So they can only exchange packets when they are in the communication range of each other. Same holds for the nanobots, but between nanobots, we can only exchange packets if we are in the communication range of 1 centimeter to each other. In a first evaluation, we sent a packet from the smart device to the nanobots at a point in the simulation when the nanobot distribution is only changing slightly anymore. We also decided to let nanobots only try to copy that packet to other nanobots once per simulation second. So now we have 2 scenarios, one with 1,000 nanobots and one with 6,500 nanobots. In the beginning, you can see that there is a strong increase in nanobots receiving the packet. It takes 1 second for the large population to reach half of all nanobots, and it takes 2 seconds for the small population. So what you can also observe is that it takes pretty much time until the last nanobot receives the packet. For 1,000 nanobots case, it is 145 seconds, and for the 6500 nanobots case, it takes 63 seconds. Another thing you can observe is that in the 6500 nanobots case, the curve is increasing stronger than for the 1000 nanobots case. So where do these effects come from? These effects are mainly coming from the distribution of the nanobots, since they are not equally distributed. And in my thesis, I found out that the most of the nanobots are in the upper body and way less are in the legs and arms. So there are often gaps between the nanobots where they can't communicate with each other. So this was my short presentation. Thank you for your attention, and I'm curious for your questions.